My name is Weston Mulqueen. The date is April 10th, 2023. Weston Mulqueen. So, hello, and thank you for joining me. What I'm going to talk about today is the interaction between the eukaryotic cells, more specifically the macrophage, and the prokaryotic cell, or more specifically tuberculosis, or Mycobacterium tuberculosis. It is thus going to be called either Mycobacterium or TB from here on out. So first we're going to kind of break down what TB is and what a macrophage is and what that looks like before we can fully understand this interaction. So first, on the left here, you have tuberculosis. Now, it looks very similar to a lot of the prokaryotic cells. It has pili on the outskirts. It is encased in a capsule. It also has a cell wall right here, and then it has your cytoplasmic membrane. Now, on the insides, it looks very similar to that of a bacteria. Okay, we have the nucleoid right here. We have the cytoplasm, which is the liquid inside, and then we have the studded ribosomes. Now, this is what TB looks like. Now, if you kind of transform over to what a macrophage looks like, it's kind of an oblong shape. It doesn't have really a definite structure, but it has all of the components of a cell. You have your nucleus, you have your Golgi apparatus, you have your lysosome, you have your endoplasmic reticulum, you have your phagosome, which is going to be very, very important for this interaction. And you also have your mitochondria, which is, the powerhouse of that macrophage. And so what interactions we're going to be looking for here is more specifically with the phagosome and the lysosome. All right, so let's look at this interaction. Now, as you can see, we have our macrophage. And tuberculosis is caused by the bacterium Mycobacterium, and it can infect both prokaryotic and eukaryotic cells, within the human body. In the initial stages of this infection, the tuberculosis enters the body through an inhalation of droplets containing that bacteria, and therefore it is very contagious around the world, and it is engulfed by these immune cells that are, of course, called our macrophages, which are the eukaryotic cells. But tuberculosis has developed mechanisms to survive and multiply within these macrophages. And so we're going to kind of look at how it evades this host immune response and establishes itself as an infection. All right, so we have our tuberculosis right here, and that is going to get onto one of these macrophage receptors. And so then it's going to be kind of uptaked into the macrophage. And so once it's inside the macrophage, it resists being killed by preventing it from basically being lysed in the internal environment of a macrophage. Now, this lysis is necessary for killing the bacteria, and it's usually done by this lysosome. And so when it enters the macrophage, it is mediated by this phagosome. So normally the prokaryotic cells will be engulfed and then taken to fuse with the lysosome, thereby killing it. But MTB has started having this other receptor called cornin-1, and it blocks the fusion of this lysosome by this calcineurin. And so in a normal way, it goes from this phagosome to the lysosome to be lysed, but because this is actually blocking this lysing step, it's actually just going to come out as this tuberculosis. And because of this, the tuberculosis can, alter the host's metabolism and making it burst basically and releasing more of this tuberculosis into the surrounding tissue because it wasn't lysed. Overall, these infections of tuberculosis, are very complex. And so this is kind of a rudimentary step of it. But thank you for watching.